Welcome to the second Zcash engineering office hours, but it's also kind of the first because it's the first one that we're doing on Discord here, which I think is a better platform for this kind of thing than Spaces. Mostly because I can share my screen and we can have more of a dialogue about this. I would love it if these became like that. Maybe we can have people present, or we can have people do demos, or just, to have more of a discussion. I do have some slides to kind of walk through today's topic, which is building Zcash apps. But beyond that, it'd be great if people chimed in. Before I get into the slides, what are people working on? If somebody wants to just either put it in the chat or unmute, I think it'd be a great place and time to show any apps that people are building or have built, or things that people are designing, memes you've created, just sort of like, let's just see what products people are doing. So yeah, I'll give a moment here of silence for people to chime in. Mina says, design for Zcash Brazil social media. Yes, actually, some of the graphics that Shielded Labs has used in some of our social media was designed by Mina. So if you need, for your design and social media needs, there's a capable person right there. There you go. That's awesome. All right. And also, I should give a shout out to Zcash Brazil, Michael 2XL, Yogi, and others. I apologize if I'm leaving anybody out, but this is being rebroadcast and translated into at least Portuguese, if not any other languages, by them. So Zcash Brazil, thank you for all of that. Super awesome. Very, very cool. All right, I'm going to attempt to share my screen now. Cool. Okay. So we are here talking about building Zcash. How does it work? I have an idea. I want to do something that involves the Zcash blockchain, which does some things. The Zcash blockchain handles transactions mostly. So financial transactions of sending ZEC from one person to another, but those transactions have memos in them, and those transactions are encrypted. And those are the things that you need to think about. Apps. Those are kind of the only things that you need to think about. That and key management, secret key management. We'll get into that. Typically, you just leave that to the user and you don't manage keys. That's the best and most secure way to do that. Our goals in this office hours demo or a presentation is to just understand the stack itself. I know a lot of people are probably coming from web applications or traditional desktop or mobile applications where there's an expectation there, and blockchain apps just in general buck that expectation. Peer-to-peer apps, because they're non-blockchain peer-to-peer that have the same sort of architecture stack thinking about here, but we're talking about blockchains. Next goal is to sort of pick the right integration depth. So you might just want to receive ZEC for payments, or you want to build a merchant tool that does that, or a store, no problem. But you might also want to do some sort of privacy native chat app or some other thing. There's many such cases. We want to understand the primitives that you're dealing with, like the addresses. What is an address? What is a memo? What is a viewing key? And you want to be able to leave with some sort of intuition or inspiration. I would hope that you're like, oh, hell yeah, I'm going to go make something. So what's different between traditional apps and blockchain apps? Traditional apps, you have sort of a client-server relationship. Your phone connects to some server out there. They have a dialogue, and there's authentication, and they provide data, and you perform actions on data, things like that. And it's all very transactional and stateful, all that stuff. Blockchain apps, it's more of a network of nodes that you're connecting to through whatever node you have access to. So you run something, it connects in a peer-to-peer way, they pass messages, and everybody arrives at the same global state. And it happens trustlessly in a peer-to-peer way. That is the primary innovation, this trustless state that we all have verifiable cryptographic access. To access that, you would typically run a node, and you would open up the RPC endpoints on that node to yourself. And that way you can still have that sort of client server thing, but it's just one of many nodes on the network. Then you would submit transactions to that node. That would get propagated up into the blockchain. The state disperses and calculates, and then everybody ends up with the state of that is the result of your transaction. And then your local app, again, sort of reacts based on shared state. That results of your transaction. So what does that look like in practice? You have this sort of, the first thing that we talked about is the full node. So this is like the heavyweight program that runs on your computer 24/7, that is going to receive blocks from the network, calculate the new state, and then store a cache of that locally. This is the most resource intensive thing, both in terms of CPU and RAM, but also primarily just storage. You need 300 gigabytes of storage now and counting linearly. So that's the big thing. And because it's heavyweight, you might end up doing things across all that block data that you have. You have all the data. I'm going to use all the data. And I want to grab 1 million blocks and perform this calculation across the whole thing. Well, that's very expensive and CPU now. So you have what's called an indexer. And this is Light Wallet D, Zino, and shout out to Rhyme, which is a new indexer that just popped up. I have not looked at it. I have no idea if it's any good, but it was a Cypherpunk submission and it looked very promising. So shout out Rhyme. Any opportunity I get to call out a cool community thing during these, I'm going to take it. So keep that in mind. And then finally, at the end of it all, you have your wallet, which again is a program that's running, that's performing specialized calculations. Oh yeah, what the indexer does is it takes those 3 million blocks that I mentioned and sort of crunches that calculation down into an aggregate, or an index, as they call it. So then you can very quickly access, there's compact blocks. We'll get into the actual like API specs at a certain point. I'll show you the links and then finally your application layer. You're probably going to want something like a transaction watcher service, because if you're responding to payments, you want to know kind of exactly when that hits the mempool and exactly when that becomes enshrined into a block. And then finally your application, which we're back, like log in, log out, website. All right, so at the bottom of it all is your full node. This is Zcash D and Zebra D currently. I believe there's a ZCG proposal for a new Go node. I'm in support of any type of node implementations if you want to really build a Zcash app. But this is your consensus state. This is all the blocks. This is visibility into the mempool, your database storage. This is everything. This is the blockchain. The full node is called a full node because it is the full blockchain. It's obviously very useful and very crucial, but very heavyweight, which is why, again, we have the index. These are currently Light Wallet D and Zino, and again, Rhyme. I'll add them here. And turns the raw chain data into these wallet consumable indexes, which is your compact blocks and note detection. And it really just speeds everything up. It's like putting an index on a database. You know where to look for things, you know how to optimize queries and things like that. These are specialized tools for application developers, primarily wallets, which is called, why it's called Light Wallet D. It's also important to note that the tools are kind of in flux right now. So Zcash D is actively being deprecated. This was a Bitcoin C++ code base. It was a direct fork of Bitcoin D with the Zcash stuff built onto it. It's just become outmoded, if you will. And we just, we want to move to a memory safe language. We want to move to a modern language, hence Rust, hence Zebra. There's complications though. First off, Light Wallet D is sort of the glue, and it's a separate program. There's no plans that I'm aware of to deprecate Light Wallet D, but there is a replacement called Zino. And that is still heavily used. And, when you open up Zashi or Cake Wallet or whatever wallet you use, Y Wallet, it will connect to a Light Wallet D. And I don't think there's maybe the Zingo wallet itself connects to Zino in production, but Light Wallet D is still the main. Zcash D, it's going to be replaced by what's called the Z3 stack. It's going to be Zebra D, the Rust full node, Zino from Zingo Labs, which will be the new Rust-based indexer, and Zale, which is going to be the Zcash D wallet. Zcash D also has a built-in wallet, which we'll see when we look at the RPC endpoints. And Zale and Zebra separate those two into two separate programs. So the Z3 stack, the full node, the indexer, and the wallet. All right, so before we get into the RPC tooling, I guess any questions, first of all? Is this helpful? I'm trying to sort of build from the ground up here, but let me know if you have any questions or interrupt me for any other reason. Otherwise, we'll move on to integration depth stuff, and then we'll get there. Just use T addresses. So this is like, if you're a nonprofit and you want to accept donations from a community, maybe it behooves you to just have that in a T address, and so everybody can see the amount that's in there. Whatever. There's plenty of reasons why you would want transparency, whatever address. This is not any different than a Bitcoin implementation. And, you would just share your QR code. You would use a Light Wallet D API to sort of, ping that address, wait till a transaction happens, or watch the mempool if you want to be super responsive, and then, unlock a product or do some application thing after a certain number of confirmation. Usually just means however many blocks are above that transaction, between that transaction. Wait a minute, this is Zcash. We're here for privacy. So how would you make an app that's sort of private by default? The answer is with a shielded transaction with a memo and a viewing key. That's sort of the transparent for one person, or constrained transparency model. And there's some constraints built in there. You have to, it's more complicated. It's more steps. So there's potentially more wallet UX. Every shielded transaction that you submit to the blockchain incurs a cost on the commons, because the wallets are going to have to do what's called a trial decryption and try to unshield those transactions. There's been a lot of advances in syncing technology since the old days, since like the sandblast, which was really good, which mitigates a lot of that. Keep that in mind. There may be a way to do aggregate memos or something like that mitigate some of that scanning cost. They're the memos themselves, which are 512 bytes, which I think adds up to 511 characters, interestingly enough, because there's probably some control character or something like that takes up a byte. There's fees involved, so you can't just like have a full open messaging service with Zcash, because you still have to pay a marginal. And then there's certain light client limits, primarily around security. There's things that you can rely on the Light Wallet D for. There's certain pieces of data that you can rely on it for, and there's certain pieces that you can't. There's something called the Wallet App Threat Model, which I can link to. Wallet App Threat Model, and that basically defines an adversarial relationship between the client and the Light Wallet. The threat model always assumes that the Light Wallet D server is adversarial and sort of reactingly. So you can get mempool data from it, but you can't get like key decryption data from it, or so, things like that. We can look at that page itself. I don't have it committed to memory. So again, we have the chain, the indexer, the wallet, light client, and then your app backend and front end. And each one of these is a place where metadata leaks could potentially happen. Probably here, if we're being honest, there is a security flaw in your app. You should check your app first and then go to this stuff. These are pretty well studied. They're not perfect. But your primary metadata leak is probably going to be somewhere in the app. You can do things like at this spot between the indexer and the wallet, introduce Tor, which Zashi does, to reduce network information disclosure and traceability. But whatever. You're going to want your front end in your wallet. So you'll see a lot of applications like our good friends over at Zerdinals. Have a wallet built into their app, and I saw a new desktop wallet, but maybe you just want to I just got distracted by the chat. You want to bundle a wallet with your app, with your front end. You still want the users to store their own and deal with their own keys, so maybe you have some sort of local storage for that. Then your back end is going to sort of interact with the indexer and then re-index things again into a database of your own choosing. So it's like a lot of consolidating and aggregating data. That's like all the data's up here, and then it gets like narrower and more specific to your actual use case. And we'll walk through what a watcher service might look like in a minute. So yeah, I'm going to skip that slide. So again, the Zcash primitives, we have your address types and your receivers. This is a receiver is a fancy word for when you paste your address out into the world. You're sending a receiver. Like, here's my U address, which is my receiver. I want to receive some Zec. And that sort of directs it to a, sapling. Like, the Z address will go into the sapling pool. The U addresses will typically go into the orchard pool. Those would encrypt some sort of memo in them, which is a fun way to just send a payload of data. You'll always just usually the memos are human to human, so you'll write a note, be like, "Hey, Mark, here's 0.1 Zec for whatever." But you can also put like JSON in there, or you could put binary in there. It's just bytes. You get 512 bytes. And then again, your viewing key, which is like, I want you, whoever you are, to receive this transaction. No, wait, I want a third party. I sent a transaction or I received a transaction, and I want to provide a decrypted version of that transaction to a party of my That's where you provide a viewing. There's like a UF key, a universal viewing key, which is sort of like, here's everything that was sent to this address. And there's incoming viewing keys, which I believe are just things that were only sent and not sent to, but not sent from that. Zec Hub, shout out to Zec Hub. They have a bunch of really good, they're like a glossary of all these terms. So if you're ever like, what the hell is this Zcash thing? Zec Hub almost certainly has a page about, for example, viewing. Yes, I can share the presentation. I'll share it on my X account after this, or I'll post it. Maybe I'll upload a PDF or something. Okay. And then I'll skip another slide. But finally, just commit this to memory. If you're working locally, you can just kind of raw dog mainnet because it's resilient and you can just develop apps against it by just sending yourself transactions. But if you're doing more intricate stuff, or you want repeatable tests and test vectors and things like that, there's something called Reg, which you can enable via the Zebra configs, and that basically just gives you your own tiny little blockchain separate from anything else in the world that you can run tests, you can do application development, things like that. You can also set up observability because then you can just point your observability stack to mainnet and voila, good things. So it's good to bake that in while you're local development. Good to bake observability, or at least just visualization. Is anybody here familiar with the Handmade Hero YouTube channel? A lot of the hires that we have at Shielded Labs are from this Handmade Hero community, which is like, we're going to build this game from scratch. But it turns into these principles like visualization is really important. If you can visualize your data as soon as possible, do it, which is why like the Crosslink visualizer has really cool stuff, because we just did that from the ground up, and it really helped. So shout out to Handmade Hero, and check that out and visualize stuff. It's very good. All right, so those are my slides. I just want to go through a couple good pages here. One is zcash.github.io/rpc. I'm going to put these in the chat now. Zcash D, for better or worse, is sort of still the great granddaddy of all this stuff. So this has everything, including all the wallet stuff. So if you look over here on the right, get address balance. What's the balance of this address? Here you go. Block hashes, block headers, just kind of everything you would ever need from the blockchain. This RP. I believe that Zebra has to be has parity with most of them. There's a couple calls in here that I believe they decided to deprecate because, is Paku here? Shout out to Paku, the DevRel engineer. Paku's done extensive research on which exchanges use which RPC endpoints and which ones we can get rid of, which ones we can't. So there's a lot of really thought that has gone into all that. But most of this will be available. And again, just try it out. If you're running Zebra D locally, just try out these and see if they work. But the main thing to call out here is that Zcash D has all these wallet calls, and Zebra is not going to have. Then one layer above that, we have this. Oh no, channel's full. How many people are allowed in here? Shit. Well, sorry. We'll use the stage next. Anyway, one step above this is going to be the Light Wallet D thing. So it has these sort of compact blocks. It has ranged queries for blocks. It's sort of like a quality of life improvement on top of the full node. There's a zip that's really important too, so you can understand the full intention behind the Light Wallet D protocol. It's always good to read the zips, always. There's a lot of time and effort goes into making sure that the spec matches and it defines everything precisely. And it's just, if you're an implementer, it's just good to know what you're implement it. Zebra also has what's called the Open API and Swagger tooling, which codifies the API endpoints that are available and gives you this nice UI if you run it locally to play with the API. The code, the Open API spec for Zebra itself is in the repo. Make sure I grab that one. And that one. And then finally the Zyno API. Zyno is really interesting because it provides the LightWallet RPC protocol as defined in that. But it's also a set of Rust tools that you can use internally in your application. So again, for like the crosslink visualizer, which is slowly becoming sort of like the desktop, it actually directly integrates Zyno's code into it as if you use the same tooling as the rest of the stack, e.g. Rust. So if you build a Rust app, you can implement a lot of these tools. I should also call out, I don't think it's made into a repo yet, but Shielded Labs is working on a cool set of C bindings in Go, and you can do this in even Python or whatever. You can still use, like, for example, design, or like, I just saw that the Zcash Foundation released a new DNS seeder that's built in Rust, and they directly used the Zebra network from Zebra in it. So there's all these cool, like, everything's created into these little modules, and you can sort of pick and choose that if you build it in Rust. That's another integration path. So yeah, is the end of my slides, folks. Came in at just about 30 minutes, which I think is pretty good. But yeah, I want to hear from you now. Like, what are people doing? What questions do you have? What can I do between now and the next engineering hours even better? Turning it over to the, all right, how would I create a watcher for multiple addresses? I would, let's do the transparent version and let's do the shielded version, right? They're kind of similar. So you would get, you'd have a service that would be watching blocks the whole time. So every time a block comes in, let's leave the mempool out of this just for now. We're only talking about transactions that have actually been included in blocks. So starting at the chain tip, you just be kind of watching block after block, or you can do a full scan. But anyway, just imagine like a stream of blocks. Inside of that, there's going to be a set of transactions in that block. If they're transparent transactions, you're kind of done. You'd be connecting to the Light Wallet D at this point. So, you get the blocks, you get the transactions, you're going to be scanning every transaction you see. And if they're transparent, you're done. If they're shielded, you're going to be trying to trial decrypt every single one, which is that cost that you're in. You would get the UTXOs from those transactions, and then you would wait a certain number of confirmations based on your risk profile. So, maybe if it's for communication purposes, you want to react faster. If it's payment settlement, you probably want to wait 10, 20, 30 blocks or whatever until you're satisfied. You would probably store some cache data locally, like your last scanned height, so that you don't look past that, kind of like your wallet birthday height, just sort of a depth that you would keep around. And I don't think that's probably good. And then when you do the compact block, so moving over to shielded, when you scan the compact blocks in a Light Wallet, you can provide a viewing key. And the main intuition there is that a shielded transaction plus a viewing key equals transparent. That's like if you want to provide a transparent view into some sort of shielded transaction set, the viewing key is your main thing that you include there. So you'd have to either have the user provide, I think the main thing is like, it's almost like asking for like when you add an app to GitHub and it's like, we need these permissions, right? You could create a flow like that in your application that's like, in order to provide our service, we need a viewing key into this address. And then your job is obviously to be very careful with that viewing key, but it's a lot like that. It's a lot like an authorization flow. And then you could theoretically watch that. You'd probably just have the user make a new address. And then you just watch that. And then as transactions come in, you will try to decrypt them, but you will actually decrypt one. And then you look in the memo. So again, it's you can do all this stuff in the shielded world, but it just takes a few extra. Was that helpful, Squirrel? All right, awesome. Thanks, Magical Magic Man. All right, what else can I do for you all? The question is, what are the hardware requirements? They're documented. Let me pull it up. Okay, I have it on the screen on the stream there. Yeah, they recommend 4 CPU cores, 16 gigabytes of RAM. This is the big one, 300 gigabytes available disk space. Actually, I'm running a Light Wallet D and a System D container right locally, and I can tell you that my Zebra D cache is 253.8 gigabytes, and my Light Wallet D cache is 16.3 gigabytes. If I said megabytes earlier, I meant gigabytes. 250 gigabytes for Zebra and 20 gigabyte for Light Wallet. Zale will also have a cache, but I don't think in the sub 1 gigabyte. Correct me if I'm wrong. You're welcome. Michael 2XL, do you want to say anything? Or if there's any more questions also, but do you want to plug anything or shout out anything for Zcash Brazil?
Hey, yeah, I think everything was great. We just broadcast in the your presentation, and I think the translation was good. I think they have improved the system, the tools, so it was nice. Thank you for your time.
Cool. Yeah. Thank you. Does
I
anybody
think
else?
we have hacked this, so maybe available our channel.
I'm sorry. What was that?
I think our team hacked this call. I think.
Okay. Cool. Yeah. Let me know. Does anybody else have anything they want to plug or announce while we're here? Either put it in the chat or just unmute, I guess, or raise your hand. Exactly how Discord works. I'm old. Looks like some. Shout out to Zarkwing Duck just because I like your name. Question is, are there animated video ideas, Zcash, Zashi, want to be created? The people you should talk to about that there's two groups at least. There's going to be Zech Hub, because I think there are opportunities to do stuff like that. And then there's Squirrel. Help me out here. I'm not sure if these are the same people or not. That's why I'm hesitating. There's Zcash Media and the ZKAV Club, and I believe those are two separate things, but they might also be. Yeah. Okay. They're both good at least. Okay. So totally separate. Thank you. Zcash Media and so yeah, those are the three people you should check with regarding animated video ideas or motion design. By the way, if you're in Maine, I'm in Gloucester, Massachusetts. You should come to the Boston Zcash meet happening. Or there's Portsmouth, New Hampshire now has like the last Thursday of every month has an in-person meetup. Yes, thank you. January 28th, there'll be another Crosslink workshop where we run our test net and give you tools to both connect as a finalizer, which is what we call our validators, and to run a wallet, actually get your hands dirty with the faucet, getting funds from the faucet and staking them and getting a staking reward and bonding and unbonding, stuff like that. Who handles Zcash Media? I don't know the right person to talk to, but Squirrel probably would, or Zero Darts. There you go. Other things we're working on at Shielded Labs are we're running infrastructure now, which is really cool. We just spun up 4 DNS seeders. We're dipping our toes into other things right now, but no promise. And we're working on the dynamic fees proposal, which should hopefully lower fees by a lot during regular business hours, as it were, regular congestion, and then create a competitive dynamic fee market for if there is ever block congestion. You'll notice once you start running a node that the Zcash blockchain is a famously uncongested during most of the time, like less than 1%, which is great. It should be good. All right, here we go. I wonder if Zec is able to be integrated as a settlement layer for agent, working on an interpreter for agentic workflows with decoupled side effects. Interpretation consumes tokens per node executed like gas. The side effects are all metered through token spending in order to monitor and limit the effects. Do you think Zec can provide for application? I assume by side effects you mean like actual externalities, like the hardware space, or I mean storage, like block storage space and CPU usage. And okay, okay. Yes, there is a way through this. Like in Dune, there's a narrow path. Because you need all those external APIs and LLMs to accept Zec in a X402 fancy agentic kind of way. So there's a tool called Nano GPT that you can pay for in Zec, and I believe it's like you buy a bunch of tokens and then you use them type of model. So you could theoretically run something like that, and as long as your transaction data fits in that 512 byte memo, where there's proposals to expand the memo space dynamically and things like that, like memo. It's called memo bundles. It's one of the. I prefer to talk about only things that are deployed on mainnet right now. So as long as you can like stuff enough of your application layer data in that 511 bytes, and you can interact with your tools with Zcash, I don't see why not. You'd have to be very clever about it, but I don't see why you wouldn't be able to do so. I would actually like to see a lot more agentic work being done, not something we can allocate resources to at the moment at Shielded Labs. Call to the community, build cool stuff with agents. I think it's possible. There you go. That would be yeah. They said that's something I didn't even think of, making the effects of services be the same token. That would be the magic. That would be the full shielded. I mean, that's pretty powerful. The whole like shielded agent kind of thing. Creepy. Almost sounds like a 3-letter agent, but they work for us. They work for the good guys. All right, last call. We'll give you the last 10 minutes of your life back here. Otherwise, but I'm at Shielded Mark on X/Twitter. Reach out to me there, follow me there, and I will do my best to be of service to the Zcash development community. All right, thank you all.
Thank you, Mark, for our time.